All right, let's take a solution. Take a solution. Take a look at our solution for problem number 16. So they give us the parent function f of x is the absolute value function, and they describe the sequence of transformations, and they want us to come up with the final equation. So if I just apply this one at a time, this first transformation, it says to shift to the graph of f to the left 2 units. So I know that shifts left and right are bizarre in their behavior. That to the left is actually x plus 2. So if it were just that alone, it would be the absolute value of x plus 2. But now they want me to, it says then, so then using this graph, create a new graph that is a horizontal shrink by a factor of 1/3. So whenever you're affecting inside the parentheses, it's bizarre in the behavior, I have to take the reciprocal of 1/3. That's how you get a horizontal shrink by a factor of 1/3, is to write it as 3 times x. So with respect to our equation, we've now built this equation to be the absolute value of 3x plus 2, because what the function g is doing is whatever you give it, it takes the input and adds 2 to it, and then takes the absolute value. Well, the input is 3x, so it's going to add 2 to that, and then take the absolute value. Now finally, we want to take, I said finally, so I can call this g. So I've built this up to get this final function. Yeah, I just didn't know what else to call it, so I just number it all the time to get to my final answer of g. It says to shift it down 1 unit. So I take the graph, the previous graph, which was g2, and to shift it down, you just subtract 1. So the expression that we have for that previous graph was this absolute value of 3x plus 2 minus 1. So let's come over and jump to that Desmos graphing calculator. I was playing around with this earlier, and I think I've already got it typed in. Yeah. So my parent function is this absolute value of x. To shift this to the left 2 units, it actually is x plus 2. So that shifts it to the left. Then to have a horizontal shrink by a factor of 1/3, it's going to shrink in towards the y-axis, not towards an axis of symmetry. So this is going to squeeze in these x coordinates like this guy is to the left -1, is now just going to be to the left -1/3. Okay, so you see how it's squeezed in, and let's remove these other ones. So again, we have the absolute value of x, we shifted it to the left, and now we have a horizontal shrink. It's going to squeeze in towards the y-axis, and you can see that vertex did, if I divide that by 3, -2/3, that's roughly, yeah, you can see right there, -2/3 as a decimal, -0.6666667. It just rounded it to 3 decimals. So then I want to take this graph and push it down 1 unit. So that's the description that I have. But see, I wrote my answer using function notation. They just want an equation. Well, that equation is this, and you can see that that's the same thing that we get. So I know if I knew nothing about this transformations that, hey, that's my final answer. So this equation right here is my final answer, that g of x is the absolute value of the quantity, 3x plus 2, then subtract 1. Hope that helps. Talk to you later.